Okay, this is your Chapter 3 final exam on powers. All of the questions that are here cover all of the outcomes from N1 as well as N2 and N4 in your curriculum guide. So the first 4 questions or 6 questions? 6 questions are true and false. So the first question says 5 to an exponent of 4 is equal to 5 plus 5 plus 5 plus 5. And the answer, of course, is false. Because exponents, when you have a base of 5, what they show you is repeated multiplication, not repeated addition. So 5 plus 5 plus 5 plus 5 is actually equal to 4 times 5. And 5 times 5 times 5 is 5 to the exponent of 4. Question 2. This is a tricky question because it looks like it's negative 2 in brackets to the exponent of. So if it's this is defining the brackets right there, defining the base as negative 2, which means in repeated multiplication, it is negative 2 multiplied by itself, which would have a standard form of 1. However, in this situation, the base is not in brackets, the entire power is. So therefore, it is the opposite of 2 squared and is negative 4, which is exactly what this says here as well. So therefore, this answer is true. They both say the same thing. Question 3, you have a power of negative 2 cubed multiplied by negative 2 to the 5th divided by negative 2 to the 4th. So the work I was hoping to see here was that you would keep the base and add the exponents for the top part to get negative 2 in brackets to the exponent of 8, negative 2 to the exponent of 4. And then once you have that, you're dividing, so you're going to keep the base and subtract your exponents to give you a final answer of negative 2 to the 4th. And since that is not the same thing as negative 2 to the 11th, your answer is false. The fourth question says 2 plus 5 in brackets cubed is the same thing as 2 cubed plus 5 cubed. And the reason why this question even exists is because there is a law with exponents that when you are multiplying 2 numbers together in brackets, you can disperse the exponent onto both parts to give you 2 cubed multiplied by 5 cubed. However, when you are adding, you cannot take that exponent of 2 and apply it to both of these parts, because if you actually work that out, this would work out to be 4 plus 25, which is 27. And if I actually work this out in brackets, it would be 7 squared, and 7 squared is 49. So since those things aren't the same value, you can't possibly disperse an exponent across 2 numbers. Your fifth question says negative 2 multiplied by the power of negative 3 cubed, or negative 3 in brackets defining the base cubed. It is greater than 0. So obviously the work I needed to show here was to take this and actually use bedmass to simplify it. Negative 3 cubed means negative 3 multiplied by negative 3 multiplied by negative 3, which is negative 27. So once I simplify my exponents, I get that. And when I multiply 2 by 27, I get 54. And a negative times a negative is a positive. So is 54 greater than 0? The answer is yes, it is. So true is your answer. And that's all I needed to show me for work. Probably exactly like that. Question 6, in square brackets, you have negative 2 cubed. And the reason why there's square brackets instead of round brackets is because if I use round brackets, it gets really confusing looking. So the square brackets are there to show that it's a power to an exponent. And the rule or the law that you learned in section 3.2 is that when you have a power to an exponent, you keep the base, in this case negative 2, and you multiply your exponents, which will give you negative 2 to the exponent of 9. Now, some people decided that it's important to simplify that, and I don't have to, because there is a rule, there is a basic rule that we learned that when you have a negative base to an even exponent, your answer will be positive. When you have a negative base to an odd exponent, your answer will be negative. So we know this is going to be negative something, and I don't even care what it is. But a negative base to an odd exponent will be negative something, and a negative something will never be greater than 0. So therefore, your answer is false. Just for the record, negative 2 to the exponent of 9. I thought I was take this and go, what is negative 2 to to the exponent of 9 is negative 512. But I like negative something better because it shows your number sense understanding a little bit more. Your next question. It doesn't have a question number. What question number is this? 7. So question number 7 says complete the table. So negative 10 in brackets to the exponent of 6 means negative 10 is the base. And a repeated multiplication, it'll be negative 10 times 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 negative 10. And its value, well, we learned that if you have 10 to a negative base to an even exponent, it's positive. And if you have 10 as a base to an exponent of whatever number, it's really just a 1 with whatever that exponent is as numbers of 0. So we have 6 zeros. So your actual answer is positive 1 million or just a million. In the second one, you're given the repeated multiplication. It's a negative sign outside the repeated multiplication of 5 times 5, which means the opposite of 5 squared. No brackets around your negative 5. And its standard form values, the opposite of 5 times 5 is negative 25. Now, some people might consider that negative sign to be an actual negative 1. That's also acceptable to write it like that. But if you do and you simplified it, it would be negative 1 times 5 is negative 5, and negative 5 times 5 is negative 25 in standard form. And your last question is, what base to an exponent of 4 has a standard form value of 256? So really what you could have done here is probably just trial and error. If you started with, let's say, something like 5, and you worked out 5 exponent of 4, that would be 5 times 5, which is 25, times 5, which is 125, times 5, which is 625. So you're too high in standard form if you use that. So then you try something like maybe 4, and 4 times 4 is 16, and 16 times 16 is 256. So you realize your answer is 4 exponent of 4 has a value of 256. Your next question is just a basic vocabulary. 2 is called your coefficient because it's multiplying the power by 2, or it's doubling the value of that power. Negative 3 is called your base, and 4 is called your exponent. Now, it's a very basic question. If you had any of these wrong, you probably weren't really internalizing what this chapter was about, because that was almost a gimme question on your test. The next question, a lot of people screwed this up. What question number is this, by the way? 9. Write as a product of 2 powers in nice bold. So that's the first thing you needed to do for a point. Write as a single power for a second point and state its value for a third point. So the product of 2 powers. Well, this number here as a power is 2 multiplied by itself 4 times, or 2 to the exponent of 4, multiplied by 2, multiplied by itself twice, 2 to the power of 2. This is the product of 2 powers. Okay, that's your first part. You got a point for doing that. Then it says, write as a single power. So what I was hoping people would do is they actually use your law, keep the base and add your exponents, to get 2 to the exponent of 6. That is a single power. And state its value, 2, 4, 8, 16, 32, 64. Its standard form value is 64. So you got 1 point for this, you got 1 point for this, and you got 1 point for that. And this is a nice little thing because you showed your work. Again, the next question, question 10, says write as a quotient of 2 powers. Write as a single power and state its value. So 3 points for that as well. The quotient of 2 powers. So right here we have negative 3 multiplied by itself 5 times, divided by negative 3 multiplied by itself once. That is the quotient of 2 powers. As a single power, keep your base and subtract your exponents. As a single power, it would be negative 3 to the exponent of 4. That's the second point. So 1 point for this, 1 point for this. And in standard form, negative 3 multiplied by itself 4 times is a positive 81. Question 11, write as a power to an exponent. If any question was done wrong a lot, it was this one. Write as a power to an exponent. So this is 10 squared. And 10 squared is being multiplied by itself 3 times, which means I could put it in brackets and put an exponent of 3 outside there. That is 10 squared multiplied by itself 3 times, or a power to an exponent. To write as a single power, it would be 10 to the exponent of 6, because the rule is when you have a power to an exponent, keep your base and multiply your exponents. And we already did 10 to the 6 because it was part of another question. In standard form, it's a 1 with 6 zeros, or 1 million. Question 7, arrange the powers in descending orders of value. I think I did make a change on this, but I didn't write it here, so I'll just do that right now. I'll take my little marker here, change it to white, and then I'll just erase the brackets, I think, right? Didn't I make this one? Erase the brackets on the actual test, so something like this. Okay, so write in descending powers or value. So negative 5 without brackets on it squared is the opposite of 5 squared, so its standard form value for a point was negative 25. Negative 2 cubed is negative 2 multiplied itself thrisely, which is negative 8 in standard form. Negative 1 without brackets to the exponent of 22 is still the opposite of 1 to the 22, which will be negative 1. Negative 4 to the exponent of 1, any base to the exponent 1 is itself, so it'll be negative 4. And any base to the exponent of 0 will always have a standard form value of 1, so that is a positive 1 value. Oh, that's interesting. Oh, that's why we did it, right. So once you have those written, what you need to do is reorder them in descending powers, so starting with the largest number. The largest number of those is negative 10 to the 0. That is your largest number. Your next largest is negative 1 without brackets to the 22. Then you have negative 4 in brackets to the 1. Negative 2 in brackets cubed. And your smallest number is negative 5 squared without brackets. So this was where the point, a point, a point, a point, a point, and finally putting them in the correct order was also worth a point. That question, which is not number 7, was worth 6 points. Question 8, or whatever it is, 13, excuse me. It says use bed mass to solve. So we have negative 2 not in brackets squared, which would be the opposite of 2 squared, which is negative 4, plus negative 2 in brackets cubed, or the power of negative 2 cubed, which would be negative 8. So I'm looking for that for 1 point. That's worth 1 point for that one. And finally, a simplification of negative 12 is worth another point. So that was worth 2 points for that question. Your next question, number 9, gives you several powers and a little bit of brackets. 4 cubed is 4 times 4 times 4, which is 64. Minus 2 plus 4 in brackets, which will be 6 squared. Actually, I probably shouldn't have done the power yet. Actually, let's just keep it here. Hang on. I'll keep it 4 cubed. I should do brackets first. Plus 1 to the 10. So I've just simplified the brackets. And now I'm going to simplify the powers of 64, take away 36, plus 1 to the exponent of 10. If I had one person say 10, I had 10 people. 1 to the exponent of 10 has a standard form of 1. 64 take away 36 is 28. And 28 plus 1 is 29. So you got 1 point for this, 1 point for showing your work without making any mistake, and 1 point for your correct answer. Question, whatever that was worth 3 points. The next question, which is not 10, says 5 take away 8 cubed minus negative 2 in brackets to the exponent of 4. So if I take this, simplify my brackets first, I get negative 3, which is 5 take away 8 in brackets cubed, minus negative 2 in brackets exponent of 4. Because the negative 3 is in brackets, that's the base, so it's used in repeated multiplication, giving you a standard form of negative 27, minus negative 2 in brackets to the exponent of 4 is used in repeated multiplication. 2, 4, 8, 16, positive 16. If you're not great at subtraction of integers, you could always use addition of the opposite. Negative 27 and negative 16 make negative 43 in standard form. Next question says 2 cubed times 2 cubed plus 4 to the 0 times 10 squared divided by 10 to the 1. Now, you could make this an 8 and make this an 8 and make that 64. And that's probably what you should do in this particular question. Or you could make it 2 to the exponent of 6 if you wanted to use your law. It didn't matter. But however you did it, when you simplify that, you're going to get 8 times 8, or 64, plus 1, because 4 to the 0 is 1, multiplied by 100, divided by any base to the exponent of 1 is itself, 10. So then you're going to get 64 plus 100 divided by 10 when you simplify that. Or 164 divided by 10. And like I said, this was a test you didn't need your calculator for, because when you divide by 10, you simply take your decimal and move it one place over. And therefore your answer is 16.4. Next question. 2 divided by 3 squared plus 1 divided by 2 cubed, or 2/3 squared plus 1/2 cubed. Either way you do it, you probably want to disperse the exponent of 2 onto both of these, which means you're going to have 2 squared over 3 squared plus 1 cubed over 2 cubed, or 4 over 9 plus 1 over 8. So essentially what you had is the addition of 2 fractions is what this became. All right, so once you wrote that for your point, you find your common denominator of 72. Make your equivalent fraction of 32 72ths plus 9 72ths equals 41 72ths, and that is lowest terms. Oh, unbelievable how many messed this one up. Such an easy question. When you look at this question, my expectation was not you change 10 squared to 100 and 10 to the 5th into, what would that be, 100,000 divided by a million. I didn't want you to do that, obviously. I wanted you to apply your exponent laws here so that you would go keep the base and add the exponents to give you 10 to the 7 divided by 10 to the 6. All of this here will eventually become just 10. 10 to the 1, really, which is really just 10 in standard form. If you started dealing with a million or 10,000, you were missing the point that you could have applied your exponent laws to get 10. Take away, this would be 2 multiplied by 9, which is 18. Much simpler this way. 10 take away 18 is negative 8. So your answer for that question was negative 8. And finally, the last question, 20 bacterium are in a Petri dish. They will quadruple every 2 minutes. How many will there be after 10 minutes? Use the formula given. Starting number multiplied by rate of change to the exponent of time units. Honest to heavens, I don't know how you could possibly mess this up as bad as some people did when given the formula. But your starting number is 20. The rate of change is this word right here, quadruple, which is a fancy word for 4, multiplying by 4 every time. And it multiplies by 4 every 2 minutes. Every 2 minutes, how many after 10 minutes? So your exponent is not 2, and your exponent is not 10. Your exponent is 5 because it will quadruple 5 times within that 10-minute period. So the number of quadrupling times will be 5. Once you solve it, you'll have 20. And then, of course, you could just take a calculator and go 4 to the exponent of 5 is 1,024. And that will be 2,048 with one more 0. So 2,048 plus a 0 means, therefore, there will be 20,480 bacteria after 10 minutes.